Yo, it's your boy Mike with another video, and what we'll be working on today is a 3D model of our very own Raspberry Pi 4 Model B case. We'll be building this bad boy from the ground up and get this bad boy printed up with our 3D printer. So let's not waste any more time. Let's get it.
Random IT guy.
Before I begin this tutorial, I want to give a huge shout out to Deniks. A lot of my techniques derive from his learnings. Like and subscribe to Deniks' channel for more amazing guides. Alright, let's begin. What you see in the very beginning is your cube and your actual canvas. What you want to do is, what I like to do is delete everything on the scene so you have a blank canvas. Now that we have a blank canvas, I want to actually set our unit of measurements to match our slicer. I like Prusa Slicer, but there's so many out there like Cura Slicer with a 3 in it, and several others. Just find which one you like the most. But all of them use millimeters. So what you want to do is click on your very far right side. You will see your scene area. You want to click on the cone icon, go to Units, change your length to millimeters, and change the unit scale to 0.01. You will notice that your grids become missing. In order to bring that back, go up to the top, go to your viewport overlays, and change the scale to 0.01 as well. And now you will see that you have your grids back. Since we're going to be modeling a Raspberry Pi case, what we want to do is import a Raspberry Pi model, which I will leave a link in the description for you guys to download. So I'm going to come up to File, Import, STL. I'm going to go to my location where I have stored my STL file. Oops. You will notice that it comes right into the scene. This is the Raspberry Pi. You see that it's sitting on the y-axis and the x-axis, and it's sitting upward. What we want to do is rotate that on the x-axis 90 degrees. Oops. As a matter of fact, let me bring in my screencast keys so you can actually see what I'm doing. Alright, so now that I have my screencast keys on, I apologize for that. You want to rotate, hit X, 90 degrees. And now you see that it's sitting flat on the canvas. Now that we have that on the canvas, I want to change the name because I like very short names when I start doing my scene, so it won't look so convoluted on the scene. Alright. Now we can bring in an object, Shift A, cube, scale to hit S to scale to the size of your model. Sometimes it's easier to go into wireframe mode so you can see what you're looking at. And scale, go into the x-axis, scale along that. All right. And sometimes for me, I like to go around, hit edit mode, go into my faces selection, select my face, and make sure that I move my faces to match where I want exactly the case to be. And for me, I always find it easier to make sure that you're closer to your SD card slot. I want to make sure I'm as close as possible without really touching the actual Pi itself. So now we can move around with our middle mouse key, and I grab the faces that I want to scale upon, and I'm going to hit scale on the y-axis and scale outward, making sure that I am actually where I want to be as far as scaling is concerned. I tend to try to make sure that when I'm scaling, I leave a little bit of access space for the audio jack, the HDMI, and the power. So I'll leave a little space like that so you can see the audio jack. Right? Now that I did that, let's look around. I'm going to actually go back into edit mode and move the bottom of the case upward, bringing it up just ever so slightly so I can make sure that it's not going to be too massive. Somewhere around there should be good. The size really doesn't matter as long as you're going to make our actual mounts for the Raspberry Pi. So it really doesn't matter, but I like to make sure that I'm not too far along because you have to print this, so the less print area, the better. Alright, leave it about right there. Alright, now that we're looking pretty good, I think we can move this out a little bit more. Let's smooth this area out just a little bit. Barely seeing, yeah, I'm going to go a little further out. Side those edges where the ridges are for the USB slots. Alright, now we have a pretty solid looking case already. Now I'm going to get out of wireframe mode to see what we have so far. Alright, grab the top face and hit delete the faces. Yeah, that looks pretty good. Alright, now we can move on from there. What I like to do is go back to the object mode, hit Control A on the object for the cube, and go to apply scale on the actual case itself, because when we actually start doing beveling and things like that, you will notice that you will start having weird outcomes when you start beveling. Of course, I'm going to change the name, bottom case. Now that that's looking good, we can start. We can actually start making the case look a little bit better. Select the edge mode. Grab my edges. Oops. I'm going to hit my edges, hit Control B, and begin beveling. And when you scroll with the middle mouse, the more of a bevel you will have, the more lines it will create. Now, we see I have a pretty solid bevel right now. Now, I know you're wondering, hey, this looks very thin. Don't worry, what we're going to do next, we're going to go over to our right side, click the modifier properties, which looks like a little wrench. We're going to add a modifier, solidify, and right here, I changed offset to 1, so it will actually start growing on the outside instead of on the inside. So now we change the thickness. You will notice it starts gaining thickness on the outside of our case. I'm going to do probably 15. Now you have to make sure that you know what size you're looking for, because it will get, when you start printing it on the 3D printer, it starts getting a little thin. So make sure you make it exactly the thickness that you want it to be, and make sure you set even thickness to make it even thicker and make it follow through all the way through all the open areas within the case. Now that we have that, I'm not going to apply that yet, but what I'm going to do next is begin making our little holes for our case, where the USB, the Ethernet port, and the power and the HDMI slots go. So what I'm going to do is hide the bottom case, go into the top view of the Raspberry Pi, and then what I'm going to do is create a cube. Move it. To move it. Scale it upward. Now when you're doing this, you want to make sure you want to go over, you want to make it a little bit bigger than the actual holes itself, so you will actually have room for the plugins, for your USB, your Ethernet, things like that. You want to make sure that you follow thoroughly through with the sizes. I tend to go a little bit over the top, just a little bit, so I can be safe. And knowing when I print the case, I won't have to worry about the slots and the holes being too big. So now I'm going to go into wireframe mode. Tab, go to edit mode, select my faces, and then I can come over here. Control 1, so I can look at the opposite side. And I'm going to select this particular face right here. Right. Bring it up above the actual motherboard of the Raspberry Pi. Right. And then also on the top portion, I'm going to go a little bit bigger. And I'm sorry, this is actually the Ethernet port right here. So now that we're a little bit bigger on that side, now we can bring it around. Go into solid mode, or solid view mode, and then pull it forward just to make sure we're looking pretty good. Oh yeah, that looks great. That looks good. Now that we have that in place, now we can hit Control C, Control V, move over, and scale our USB slots, which should be fairly easy because all we have to do is go into tab mode, go into edit mode, select our particular face that we want to select, and pull it up. And now we are going to be set perfectly. Now, I know you're looking at my slots and I know it looks a little bit bigger than it has to be. I tend to do that so I don't have to worry about the holes yet again, but you can make a little leeway with it. Alright, pull each side of the faces in just a little bit, and boom, we're looking pretty good right there. Now I'm going to go back over to object mode, hit Control C, V again, scroll over, get over, make sure everything's sitting right. Right. Now I'm going to move that face a little bit because that face is a little bit bigger than I want it to be at the top. Right, cool. Now we have our peripherals as far as the USB and the Ethernet is concerned. Now, depending on your case, it all depends on what you're trying to do. Sometimes I don't build a case to have an audio port. Sometimes I may hide the Ethernet port since the Raspberry Pi has Wi-Fi. And sometimes I hide one of the HDMI ports. It all depends on what you're trying to do. One of my cases, I wanted to look more like a Sega Genesis and a SNES system. So I decided to hide the audio jack. I hid one of the HDMI ports. and completely hid the Ethernet port and left the USB 3 and the USB 2.0 open as well. Those were the only slots that were left open. Of course, the SD slot as well. Now that we have that done, what I like to do is select all those objects, Control J. That will turn into one solid object. And then I change the name to whatever you like it to be, USB peripherals, however you say it. I'm pretty sure I'm spelling it wrong too. Anyway, now, for the sake of the tutorial, I'm going to do all the jacks for you guys so you can see how it actually operates. So now I'm going to hit Shift A, go to Mesh, and I'm going to go for a cylinder because we're going to be building the audio jack now. I try to center it, and then I'm going to rotate this 90 degrees on the X-axis. And then it should be easy peasy, just scale up. And always leave a little bit of leeway for stuff like this, because usually audio jacks have that little extra plastic covering on top where it won't reach through. So make sure you have that good amount of open space for it. Now I'm going to move it forward. And there we go. That's already one done. Hit 1 to get back on side view mode. And what I do next, I'm going to hit Shift A, Mesh, Cube, move it to be center mass within the USB slot here. Oh, I'm sorry, mini HDMI slot here. Scale along the X-axis, giving you a little bit of leeway yet again. And then scale on the Z-axis. Scale on the X-axis a little bit more. And then I'm going to scale on the Y to make it a little bit wider. And then bring it forward here. And there we go. There goes that one. And then Control C V to duplicate it. Move it along the X-axis. I'm going to go into wireframe mode to make sure that it is centered. Get a little bit more over here. Good deal, good deal. Now I'm going to Control CV that one as well. Duplicate it. Scale on the Z-axis. Oh, that's fine. We can scale like that too. A little bit wider. Pull up to make sure that it's not into the motherboard. And then we're going to scale on the X-axis. Make it wider. And there we go. Perfect. Now, get out of wireframe mode. Grab these guys together. Control J to make it one solid object. And I'll call this power peripherals. Pretty sure I'm spelling that wrong. Don't judge me for this. I'm not a professional, I promise you. I'm not a professional. I'm just trying to show what my knowledge and get people going right off the ground, how I did. All right. And a lot of this is self-taught as well. So now that we have those guys put together, all peripherals done, now let's create the SD slot. Go 3, but I'm going to go 3, and now we're looking directly at the SD slot here. All right. Hit Shift A again, Mesh, Cube, bring it downward. Try to make it center, and then we're going to scale on the Y-axis. Now, when it comes to the SD slot, I always make this way bigger, so because I have fat fingers, so it's easy for me when it's bigger for me to actually slide in there to slide in the SD card. Now that we have that, and I'm going to scale on the X. Make it longer. and move it forward. Now I'm going to go back to 3 to record and go into wireframe mode. Make sure looking real solid. Good deal, good deal. Now that we have all that complete, of course, change this name to S slot. And now we can re-enable our case to make sure everything is protruding it. Let me click on our objects on the outside here. Moving forward, make sure that these guys are sticking outside of the case. All right, good deal. All right, now we want to grab our USB and Ethernet. Make sure they're protruding. Make sure that the SD slot is protruding. All right, move forward. Make sure it's protruding out. Cool. Now we're looking real good. Okay. All right, now that we have that, let's make sure we're on our bottom case. Make sure you're on your case. Add a modifier, a boolean. Now you want to select your peripherals. Now this is the power peripherals. Now when you hide your power peripherals, you will notice we got the holes now. Good deal. So when you're checking on for boolean, you want to make sure you're on difference, exact. Sometimes, depending on the situation, sometimes fast works and sometimes exact works. I'm not sure why. Maybe it could be my computer. I'm not 100% sure why. Sometimes fast works and sometimes exact doesn't work. But now moving on. Now we're going to add another modifier, boolean. We're going to add, you know what? Let's try something different. I haven't done this before, but what I'm going to do is make all these slots. I'm actually going to make all these an actual object of its own. We'll just call them peripherals. Alright, so now let's click on bottom case. Add a modifier, boolean. And let's click on peripherals just to see what it does. I'm not 100% sure if it does it properly. So when I click on peripherals, it completely removes everything. Now that we have our slots in place, what I like to do, since I already have this done, what I'm going to do is create a new collection. I'm going to call this backup. I'm going to copy these guys and move them in there. Now, good deal. Now we have a backup. So now when I come over here and hit apply, it will only apply. I'm going to hide that actually. So we got it here, bottom case, hit apply to the boolean. Oh, whoops. I apologize. You have to apply the solidify first, or else you're going to get something wonky going on there, like I just did right there. Now you can apply that. And now we have a solid case. And just like that, we have a case. If you want to leave it at that, you can if you want to. But I'm going to go a little step further and leave actual mount holes and stuff like that for the Raspberry Pi to sit properly in our case. So where it won't actually bend or solder wouldn't touch the plastic or things like that. So now, with that being said, I'm going to hide the bottom case and bring back in the Raspberry Pi model. I'm going to go into top view, go into wireframe mode, hit Shift A, and we're going to bring in a cube. And we're going to scale on the X. Now when it comes to doing the actual mount area, I always go further out quite a bit, making sure that I'm not really, see now here, I'm protruding the case. So what I'm going to do is scale again on the x-axis, make it a little bit smaller. Alright, there's fine. Let me hide the case real quick. We can always move this down some, move it this way. And then let's look at the Raspberry Pi model again. We can scale a little bit more on the x-axis. There we go. Now what I want to do is scale on the y. Now, don't worry about how it looks right now. I promise you, we will tweak it a little bit and it'll match just right. I'm going to scale on the Y to make it come out a little bit more. Scale on Y. A little bit bigger. There we go. Cool. Now we're looking pretty good. I'm going to move this a little bit upward, and then I'm going to come around this way and make sure that our thickness is what we want it to be. Click 1, and I'm going to bring it down underneath and scale on the Z axis to make sure that it fits where we want it to fit. Scale on the Y or Z a little bit more, and now I'm going to bring it into the bottom of the case. And now, actually, I'm going to scale it. I want this to be exactly where the case is going to sit, where the mounts are actually going to sit. So I'm going to scale on the Z a little bit more. Let's make sure that we're sitting right. Perfect. There we go. Now, this is actually what the mounts are going to be. Now I'm going to go back into the top view mode so I can see where the actual slots are. Now what we want to do, you know how we use the boolean to create the holes for the actual case itself? What we're going to do now is make it to where we're going to build the holes and the slot holes for where the Raspberry Pi will be sitting. So what we're going to do, I'm going to hide the bottom case again because that part won't matter right now. What we're going to do is take a look at where our holes and where the edges of the Raspberry Pi is. So we know we're going to have corner here, hole here, hole here, and a corner here with hole in the other corner right here. So what I'm going to do is bring in another cube. Scale it up as much as you can, for the most part. Move it to where it'll be center mass in between this. That looks pretty good to me. That looks like that'll match. Now what I'm going to do, now follow along with me. I promise you, I know this part might look a little tricky, but I promise you we'll get through it. Alright, we're going to go into tab and we're going to go into edit mode. We're going to select our faces. There we go. We're going to select the other side. And we're going to scale along the x-axis. Scale. And pull it out. Pull it out. Pull it out. There we go. Good deal. Make sure when I'm looking at the top view that the cube is not sticking more than, notice for some reason that's sticking out more, but what I'm going to do is scale it along the y-axis and bring it down, because I don't want it to be protruding the holes and covering up the holes. So now, scale that good. Now, I'm going to go back to tab and go back to edit mode. I'm going to hit Control R. you'll see Control R makes loop cuts. We're going to scroll up with the mouse pad. Boom. Now I'm going to scale it inward ever so slightly along the x-axis. I'm going to scale it. Alright, cool. Now let's go to face mode. Go into our faces. Select our face here. Select our faces. We're going to hit E, which is extrusion. Hit E, then click the mouse, and then what we're going to do is scale along the y-axis. Alright, cool. Now, next part. Over here, and select an area over here. Hit Control R for a loop cut. And scroll up to make 2 loop cuts. Click, bring it over some. Nice. I'm going to scale on the x-axis to bring them a little closer together and move them. Cool. Now we're going to select our faces. Whoops, not that face. Not that face either. We want this face, and we want this face. Alright. Now, just like we did before, we're going to hit E to extrude, click out of it, and now we're going to scale along the y-axis. Make sure it's protruding outside of the cube that we made earlier. Nice. Now I'm going to go into object mode. I'm going to call this mount. Mount. And mount. Cut. Now, click out of here. We're going to click on our pie mount. And then we're going to go to boolean yet again. And click on mount cut. And just like that, you see now we have our little cuts where the Raspberry Pi will sit. Good deal. Now, I'm going to go ahead and apply that. And then, so now we can delete our mount cut. Nice. So now, you see, we have this again. Now we have our Pi mouse set. Now, if you wanted to, you can leave it like this if you wanted to. You could leave it like this if you wanted to. I'm going to go a little step further and actually make the actual round area for the Raspberry Pi to sit into. So, yet again, we're going to hide the bottom case, hide the mounts, go into top view mode, go into wireframe mode, or wireframe view, and then we're going to hit Shift A, and we're going to make another cube. And then we're going to scale this to match precisely the Raspberry Pi, maybe ever so slightly bigger. Give us a little playroom with it. Now we're going to scale along the z-axis. I'm going to scale on the x-axis. Give me just a little bit of leeway, just a little bit. Zoom in so I'll make sure we're in the right place. Then I'm going to scale on the z-axis. Alright. Now I'm going to scale on the x-axis again. And make it to where it fits perfectly. Nice. Now that we have that done, make sure we're looking right around all the edges and things like that. I'm going to hit Control A for all transforms to make sure it actually fits all transforms so we can bevel it again. So now we want to go to 7. and this will put us back at top view. I'm going to go to edit mode, hit the edge mode again, hit edge mode, and then click on my edges here. Click 7 so I can be in the top view mode. Control B. I'm going to go a little bit more. And boom. Now, we have a very, very solid shape of the motherboard of the Raspberry Pi. I'm going to call this Pi shape. And now I'm going to bring back in the mounts. Add another modifier, click boolean, and click on which one? What did I name it? That's horrible. I'll call it Pi mount. Alright, now let's get out of here. Did I not? Whoops. That's where I messed up. I made myself confused a little bit. Delete that. I apologize for that. Pi mount. We want to add a boolean modifier and select Pi shape. Now let's take a look at it here. So we hide the Pi shape. You will notice we now have a pretty solid shape. Oh, I had to click fast. Sometimes it works, sometimes it doesn't. I don't know what that problem is. But however, you will see we have an actual indentation for where the Raspberry Pi will be. Very nice. So now we can apply that. And if you want to, you can delete that shape if you want to. And now go back into your bottom case. And now you have a solid indentation and solid foundation for your Raspberry Pi case. If you want to, you can leave it at that and go from there. But if you guys want to see how to build the top, I'll show you how to do that as well. It's very easy. So now I'm going to click this bad boy. I'm going to edit mode, and I'm going to select the outer edges. Hit Alt and Shift and Alt, and now you see we have grabbed all the edges around the full edge of the Raspberry Pi case. Now what I do is hit Shift D. Shift D makes a duplicate of the edges, like you see right here. Then what I do is click P and click selection, and now we have a selection of the actual edges, and which will be separate from the Raspberry Pi case. So now we can name this top. And then we can hide this portion, the Pi mounts. And now select the top, go into object mode with the top, tab. I'm going to hit Alt and select all again, and then I'm going to hit F, which will fill the face. Alright, good deal. Now, all we have to do is simply grab the edges again, and we can hit Extrude, or whoops, go to Tab, and hit Edit Mode, and hit Extrude on the Z-axis. Nice. And just like that, we have our top. Now you have a solid Raspberry Pi case. Just like that. And just like that, you can leave it just like that and actually print it out like this if you want to. Or you can go and make your holes where you want to mount your Raspberry Pi within the case. Go a little further and add fan slots, things like that. But from here, I think I'm at a pretty solid state where I want to leave it at. Next, I want to show you guys how you export your model to a format that your slicer can read. What you want to do is click on File, Export to STL, and place it somewhere easy to access. Make sure you click on the selection only, or else it will export the whole entire model. When you click selection only, it will only export what you have selected in the actual canvas itself. So export your STL to somewhere where you want it to be saved at. Next, what you want to do is open up your STL file by double clicking it, and I want to show you how it looks when you bring it over to your slicer of your choice. Now, what you want to do is go through the functionalities for you to save it and export it to a G-code. Hey guys, here's my 3D printer hard at work. Watching it print sometimes can be very, very mesmerizing. Here's my final printout. As you notice, I'm still learning how to print myself, so there are some issues with my printout. I tend to always have issues with the temperature of my bed to keep the PLA flat and hot or warm at times, but all in all, not a bad printout. Thanks for watching my video, guys. If you liked it, please like and subscribe and comment. If you have something that you want to learn, hit me up in the comments below. As always, bless up and happy learning. Mike out.